Okay, so question number 6. Determine the molecular geometry of bromine pentafluoride. Okay, so we would first need to calculate the total number of valence electrons for this molecule. So bromine has 7 valence electrons, and fluorine also has 7. And since there are 5 atoms of fluorine, we would multiply this by 5. So in total, we have 42 valence electrons. Okay, so now let's try to draw out a skeletal structure. So bromine would be our central atom. And then we can draw single bonds to each of the fluorines. And show all of the lone pairs. Okay, so now I have 40 electrons out of the 42. So I just need to draw my last 2 electrons on the central bromine atom. And now it has a full octet. Or it has the total number of valence electrons. The bromine actually doesn't follow the octet rule, but it's able to expand its d orbital to fit in more electrons. So I think for this question, they meant for the compound to be neutral. So let's double check and find out the formal charge of the bromine. So the equation for formal charge is the number of valence electrons minus the number of non-bonding electrons, which are the lone pairs, minus the number of bonding electrons divided by 2. So for the bromine has 7 valence electrons. There are 2 non-bonding electrons. And since there are 5 bonds to the bromine, there are 10 bonding electrons divided by 2. So 7 minus 2 minus 5, we would just have a neutral compound. Okay, so for the second part, for the actual question, we need to determine the molecular geometry. So let's analyze our Lewis structure. And for bromine has 1 lone pair and 5 bonded atoms. And if we use a Vesper theory chart, we can find out its molecular shape. So when we have, on the next page, 1 lone pair and 5 bonded atoms, we have a square pyramid molecular shape. And an octahedral electron geometry. And the hybridization of the bromine is sp3d2 hybridized. Okay, so let's see what the junior tutor said. So they have the same structure, but our central bromine shouldn't have the negative charge. I think the question meant for it to be a neutral compound. Hence, the molecular geometry is square pyramid. So I think if we did have a minus at the end. In total, we would have 43 valence electrons, and then the single electron left in our count would just be on the bromine to form a radical. So I'm not sure if that's what the question meant, but I'm just going to say that the Lewis structure and molecular shape is correct if there was not a negative charge in the compound.